in the application. Here, let me talk about isotones, isobars, and isomers. In general, first of all, isobar. Nuclei isobar in the case when the nuclides have same mass number, A. We can say they have the same number of nucleon, okay? In this case, for example, I give you an example of many atoms. For example, the argon, Ar, has 40 mass number, and we have 80 atomic number, proton. We have the potassium, we have 40 mass number, and we have 19 protons. And we have the calcium, Ca, with the same mass number, and we have 20 atomic mass, protons. So as you see, we have the same mass number. We can say all these elements are isobars, okay? Isotones, where the nuclides have same neutron number, okay? But we have a different proton number. I give you an example of isotones. We have, for example, we have the oxygen 16,8. Here we have P, we have 8 protons, and we have neutrons 16 minus 8 equals to 8. I give you nitrogen N with 15 and 7. Here also we have P equals to 7, and the neutron N equals to 15 minus 7 equals to 8. And also we have the carbon C, 14, 6, P equals to 6, and N equals to 8. As you see, we have the same neutron number. We say these elements are isotones, okay? The last one, isomer. Isomer, I mean, we have same nuclide. What I mean same nuclide? So we have the same number of A, the same number of Z, the same number of N, okay? The same one, the same nuclide. But we have a different energy state. I mean, this element, for example, we have, let's say we have carbon 6, 12. This element, it can be on this energy state or this energy state, two different energy states. It depends to the level of energy gained, okay? If we give this quantity of energy, the element will be excited to one energy level. If you give more energy, if you bombard the nucleus with more energy, the nucleus will be up to the higher level state, okay? We go to the isotopes. In the case of isotopes, you know well, in this case, you have the same number of protons, okay? We say we have the same atomic number, but we have a different number of neutrons and mass number A. For example, I give you, we talked about the carbon. We have 3 isotopes, 6 the same atomic number, so we have three isotopes, but we have a different number of mass number. A will be 12, 13, and 14. These are isotopes. I give you here a simple example of hydrogen. With the hydrogen, we have three isotopes. We have ordinary hydrogen, H, H11. If we bombard the nucleus of the hydrogen with a nitrogen, with a neutron, for example, plus neutron 0, 1, we get a new element, a new nucleus of deuterium, okay, with H1, 2. For the hydrogen, we have only one proton inside the nucleus. We don't have any neutron. But in the case of deuterium, we have one proton and we have the neutron goes inside the nucleus. We have one proton and one neutron. And outside on the external shell, we have one electron. Okay? Also, we can have some nuclear reaction to get the tritium. We bombard also with, for example, with another neutron to get a new, to create a new element, the tritium. Anyway, all these isotopes have the same atomic number, Z. How